Hello, and welcome to the first lesson of our Unit 4 Graphing Quadratics in our Grade 10 Academic Math class. So the first lesson is really about learning some of the terminology that we're going to be utilizing over the course of this unit, as well as familiarizing ourselves with what one of the three forms of a quadratic relation we're going to be seeing, and then how to graph it, so getting the plot pattern under control. So this first part is a lot of copying, so I'm just going to leave this up. Again, this would be a great time to hit pause. I'm just going to talk you through the terminology. So if you hit pause here, fill this stuff in on your own note, then at least you'll have it completed and you can devote your time entirely to listening to what I'm saying. So hit pause, copy this out, come on back and I'll talk you through it. Okay, you're back. So as I said, the very first thing that we're going to be looking at today is one form of a quadratic relation, and it's called vertex form. Now this is vertex form over here. Again, this won't mean a lot to you just yet, but you can tell that it's a quadratic because our x value, were we to expand this out, would be squared. We can see there's an x squared in there, and that's what makes it a quadratic. One of the unique things about vertex form of a quadratic is that this value here, h, and this value here, k, they actually represent the vertex of this quadratic relation. The h and k values correspond to the x and y values of the vertex. So what is the vertex? That's a good question. Let's start there. So as we learned in our pre-lesson, the shape of a quadratic, when you graph it, is called a parabola. And that's one of the words that we want to have in our repertoire when we're talking about the shape that a quadratic makes when you graph it. The next piece of terminology we're going to tackle is vertex. And the vertex, it corresponds to that unique turning point that occurs when we graph a quadratic. So I'm going to just zip away from this lesson for a second. We're going to just have a quick look up over here at these couple of quadratics that we drew back in the pre-lesson. The vertex would be right here and right here. It is that one special point that I was illustrating where it doesn't have a corresponding partner like all the other output values do. This is the either lowest, as it is in the case of these two, or as it would be in this quadratic, it also corresponds to the highest point in a parabola that's opening down. So the vertex, as I was saying, is that unique turnaround point. And as I just wrote above, and you can see it again right here, h and k correspond to the x and y values of our vertex. So a vertex will be a minimum value if the graph opens up. And again, that looks like these guys right here. Our parabola is opening up like a cup, so it has a minimum value. That stands in contrast to this guy here, which opens down, and we would call then our vertex a maximum value. So we have maximum values when our parabola opens down, and minimum values when our parabola opens up. So given a quadratic equation in vertex form, that's that y equals a bracket x minus h bracket all squared plus k, if our a value is greater than 0, so any positive value out there, 1, 2, 3, or any fraction or decimal that's positive, it means that our parabola will be opening up. This is the piece of the quadratic relations equation that tells us the direction of opening. If our a value is going to be less than 0, so any negative value, our parabola is going to open down, which I already showed you above has a maximum and sort of opens down like a frown. Something we haven't drawn in yet, but that we will be drawing in, is something called the axis of symmetry. Now the axis of symmetry, it is a vertical line that runs through the vertex, and it's sort of the line, an imaginary line, around which our parabola is reflected. So again, if I'm just going to keep referencing these guys here, our axis of symmetry, let me just change up my color scheme here a little bit. The axis of symmetry is an imaginary vertical line that runs all the way through the vertex vertically up and down. So that's the axis of symmetry. And again, you can imagine that, let me just change up my colors again. You can imagine that this half of the parabola that we've made is then reflected through the axis of symmetry on the other side. So think of it as the point that goes through the dead center, or I guess the imaginary line that runs through the dead center of your quadratic relation. That's the axis of symmetry. And when we label the axis of symmetry, we label it x equals h. Now, we label it x equals because it is a vertical imaginary axis, and we label it h because that's the point that it goes through. So again, if we're going to talk about this guy here, and I were going to label it, you'll see that the h, or the x component of the vertex, is -7. So I would label my axis of symmetry x equals -7. So that's what an axis of symmetry is, and that's how we label it. The points where the parabola intersects the x-axis are referred to as the x-intercepts, or zeros. So x-intercepts we've heard before. Zeros is a bit of a new terminology for us. And when we're dealing with parabolas, there could be 0, 1, or 2 x-intercepts. We're going to talk more about that as we go along, so don't spend a lot of time on the why, maybe just the what. Times when our parabola crosses the x-axis are called x-intercepts, or zeros. And the point where the parabola intersects the y-axis is referred to as the y-intercept, which should be very familiar to you, since when you were graphing lines in grade 9 and in the start of grade 10, we used the slope y-intercept method of graphing. So we're familiar with what the y-intercept is and where it's found. Now I'm going to just put this sketch up here, or leave this sketch up here. This would be a good time to pause and just copy down these two graphs. They have illustrated both this one over here represents a minimum, so a parabola that opens up, and this one over here represents a maximum, a parabola that opens down, and I've written some information on there. So hit pause here, copy these two sketches out, and then I'll just talk through them a little bit before we move on. Okay, so you've got them up and labeled. What I want to point out in the first one here is that because our parabola opens up, whatever quadratic relation it is that we're graphing, it will have an a, whoops, let's get that with a highlighter, it will have an a value that's larger than 1. So a positive value, our parabola opens up. I've highlighted the two x-intercepts here. There is our vertex here at the bottom, and it is point h and k, depending on what h and k are. And I've labeled our axis of symmetry, that's this dotted line here going through the vertex all the way up and down. I've labeled it as x equals h, whatever that happens to be. It also just so happens that our vertex corresponds to our y-intercept in this question, or in this sketch. Let's have a look at the second sketch. So because our parabola opens down, you'll see that a is going to be less than 0, so it would be a negative a value, indicating that our parabola is opening down. Again, we've got our vertex up here, h and k, and we've labeled it as x equals h, whatever our h value happens to be. We have our two x-intercepts on here, and our y-intercept happens to be the vertex in this case again. So that's some terminology that we're going to be using, or that I'll be using over the course of the unit. Hopefully it makes sense, and you can come back and reference this video moving forward. I'm going to do part B here before we move on to the plot pattern, and that will sort of conclude our first video here. So let's have a look at some quadratics in vertex form, and we will write down the following information: the vertex, direction of opening, equation of the axis of symmetry, and whether it's a maximum or a minimum. So let's start with the first one. We have y equals negative bracket x minus 5, close bracket, all squared, plus 3. So what is our vertex? So this is a little bit tricky, actually. Since our vertex is h and k, and the h and k values are right here. So your temptation is going to be to state the vertex is negative 5 and 3. However, I want to point out that all the way back up, actually, never mind, we don't have to go all the way to the top, it's actually just right here. When we look at this version here of a quadratic in vertex form, you'll notice that there's already a negative there in this bracket. So the value, when we talk about what h is equal to, say in this case right here, h is not going to be equal to negative 5, because if we put a negative 5 in there, and just follow along, you don't have to write this down, but if we had x minus negative 5, that would actually look like, with these two negatives here knocking up together, that would actually look like x plus 5 all squared. So that it looks like a negative 5 is a little bit misleading because it is actually a positive 5 that is in that bracket as the h value. That will make more sense as we go along, even if you don't understand necessarily the reason for it, as long as you remember that it is the opposite of how it appears. That's definitely the important part. Okay, so let's have a look at the second piece. The second piece is going to be the direction of opening. So if we look to the a value for that, the a value in this case is negative, now it's invisible, but there's a negative 1 there. So with a negative value for a, the direction of opening of our parabola is going to be down. And I'm going to jump to the last question. Since we know a parabola that opens down, so kind of looks like this, we know that it has a maximum value. Not a minimum, but a maximum, a highest point that it reaches. And that's the unique thing about a parabola, is that this parabola is going to go down forever and ever here. It's never going to like cycle back up and go all of a sudden like, oh hey, let's just jump up here. A parabola won't do that. A parabola is only ever going to continue down here. So a maximum value is what we have when our parabola opens down. The last thing we want to note here is the equation of our axis of symmetry. And as we know, x is equal to h as we label it, and our h value is 5. So our axis of symmetry will be labeled x equals 5. So let's try another one of these. Maybe if you're feeling good about that one, you can pause and just try the second one here on your own, and then come on back and we'll see how you did. Do that now. Okay, now you're back. So let's get the vertex going on. The vertex of this, as I said, this looks like a plus 4, but actually it is x minus negative 4 all squared. So this is going to be a vertex actually of negative 4 and negative 2. The direction of opening for our parabola, you'll notice that there's an a value up front here. It's invisible, but it's a plus 1. And because that's positive, the direction of opening of our parabola will be up, and that will look something like this. So parabola opens up, there we go, and we'll notice that our vertex is a minimum value, because as before, this parabola is going to keep going up forever and ever. It's never going to just all of a sudden turn around and come back. So that's the lowest point we're actually going to reach. The last thing we want to label here is our axis of symmetry. Now again, our axis of symmetry is x equals the h value. We can see the h value right here is going to be negative 4. So our axis of symmetry will be labeled x equals negative 4. So there's the first part of our first lesson on quadratics in vertex form. I'm going to do part 2, so come on back.